deep within the heart of the dense, ancient rainforests of Central and South America, where sunlight struggles to reach the forest floor. A creature of myth and power reigns supreme, the Harpy Eagle, a predator unlike any other. It descends from the towering canopy with a speed and agility that defies its massive size. These birds are masters of the hunt, their very presence casting a shadow of fear over the forest. Relying on an unparalleled combination of sharp vision and acute hearing, they scan the thick verdant foliage, always searching for their next meal. Their eyesight allows them to pinpoint prey from incredible distances. They are equipped with talons powerful enough to crush bone instantly. The harpy is also capable of lifting prey that is as heavy or even heavier than itself. As one of the largest and most formidable eagles in the world, the harpy is truly a giant among raptors. They possess a wingspan that can stretch to over 2 meters, and their wings are specially adapted for navigating the complex, tangled undergrowth of the rainforest. Although they may weigh in excess of 10 kilograms, they are capable of astonishing flight speeds, reaching up to 80 kilometers per hour. The speed, combined with their heavy body weight, means that they can inflict a devastating blow upon impact with their victims. The harpy is regarded as one of the most powerful avian predators on the planet, and if you happen to be a sloth or a monkey, unfortunate enough to live within their hunting territory, you would most likely agree. It's not just their incredible physical attributes that make harpy eagles such formidable predators. These large birds are exceptionally intelligent. This is clear from the fact that they hunt a wide range of prey, including primates, some of the most intelligent animals in the forest. This constant competition between predator and prey has resulted in an extraordinary evolutionary arms race of intelligence. Both species continuously push each other to adapt and evolve, consistently creating new offensive and defensive strategies. It's this ongoing struggle that has made the harpy the unparalleled force that it is. Their unique combination of mythical power, sharp intellect, and unmatched hunting skills make the harpy eagle a true monarch of the sky. How has nature crafted the harpy eagle into such a formidable predator? What makes it one of the most feared hunters of the sky? The earliest recorded descriptions of the harpy eagle can be traced back to Carl Linnaeus's work Systema Naturae, published in 1758. He classified the bird as V. harpia, inspired by the harpy, a creature from Greek mythology. The mythical harpy possessed the body of an eagle and the face of a human, and this is where the common name of the bird comes from. And the human-like face is one of their most striking characteristics. This comparison was largely due to the harpy eagle's distinctive facial disc. The facial disc is a circle of feathers that surrounds the bird's face. These feathers can be moved and adjusted by the eagle as it wishes. When the feathers of the facial disc are raised, they act as an acoustic amplifier, directing sound towards the ears located on both sides of the head. This is similar to the way that humans might cup their hands behind their ears to hear sounds more clearly. By doing this, the eagle can pinpoint the precise location of their prey in the darkness of the dense forest. To improve their chances of success, the harpy eagle often sits patiently and completely still while waiting for their prey to come within striking distance. To further enhance their ability to find prey, the harpy eagle has developed the most exceptional eyesight of any animal on Earth. They are capable of spotting even the smallest of prey, measuring only a few centimeters from an astonishing 200 meters away. Their level of sharpness and ability to observe details far surpasses that of humans. To better understand the capabilities of their vision, scientists devised a clever experiment. They trained harpy eagles to fly down a long tunnel towards 2 TV screens. On one of the screens, the eagle was presented with an image of stripes, and they were rewarded with food for landing on this screen. The other screen was a solid gray color. Once the eagles had learned this, the TV screens were separated from each other. Now, when the trial began, the eagle had to make a choice of which screen to fly toward. During the trials, researchers measured the distance at which the eagle could still differentiate the stripes on the screen and reliably choose the correct screen for a reward. The results showed that harpy eagles could distinguish details that were 4 times smaller than the smallest detail visible to the human eye. This incredible vision is due to some key characteristics of the eagle's eyes. The first of these unique traits is that eagles have eyes that are larger relative to their body size. In fact, they are around 1.4 times larger than the eyes of other birds that are similar in weight. The shape of the eye is also important. The tube-like shape of the eagle's eye helps to create a larger image on the retina. And it is this image that is converted into neural signals by the light-sensitive elements of the eye. The more photoreceptors an eye has, and the smaller the distance between them, the better the vision. The smaller the distance between the photoreceptors, the smaller the details of an image that the eye can distinguish. However, packing numerous photoreceptors over the entirety of the retina is very energy-intensive. This is why animal eyes tend to have specific central areas with dense clusters of photoreceptors. These areas are called foveas, and it is these foveas that provide the sharpest view of any part of an image to the brain. Harpy eagles have significantly deeper foveas than most other animals. This is what provides them with their extraordinarily sharp vision. Specifically, Harpy eagles have their sharpest vision within their peripheral field of vision, at around 45 degrees to the left and right of their head. They use this to spot prey from a distance. But hunters like the Harpy eagle have something that is incredibly rare among other animals: a second, shallower fovea. This specialized area of the eye allows them to have sharp vision in their frontal visual field, specifically within a 15-degree range to the left and right of their head's central axis. These two foveas give the eagle the unique ability to see two sharp images simultaneously. This is why you will often observe birds of prey, such as the Harpy eagle, constantly turning their heads when they focus on an object. They cannot rotate their eyes within their sockets, so head movements are necessary to focus the object between their deep and shallow foveas. While possessing two sharp fields of vision is a distinct advantage for a predatory bird, this feature also brings about a conflict in many birds of prey, particularly those that attack at high speeds. The faster they fly, the more difficult it becomes to use head movements to observe prey. The act of turning the head at speed results in significant aerodynamic drag, which slows the bird down. To overcome this problem, most birds of prey do not approach their prey in a direct line. Instead, they often swoop in a spiral pattern, keeping their head relatively straight and using one eye angled towards their prey. Unlike these other birds, the Harpy eagle doesn't fly with speed and power, dives like other birds. But even at 80 kilometers per hour, they still must remain conscious of aerodynamics when hunting. The wingspan of a large Harpy eagle is often greater than the height of a human adult. They can have a wingspan of up to 2 meters. Notably, female Harpy eagles are often twice as large as males. Although their wings are massive, they are actually quite short compared to the rest of their body and other similarly sized birds. To illustrate this, the Andean condor has a similar body mass but a wingspan that is over 3 meters. The reason that the Harpy eagle has shorter wings than other large birds is because they are not built for soaring through the open air. Instead, they are specialized for quickly moving between trees in the thick forest undergrowth. Their short, broad wings make them exceptionally agile, and these adaptations allow them to fly almost straight up and attack their prey from below as well as above. Just like all other flying birds, the Harpy eagle is able to fly thanks to the unique structure of their flight feathers, which are also called remiges. Unlike other types of feathers, remiges are anchored to the bone, and their main purpose is to generate both thrust and lift. For example, if these feathers are raised and flared outward, the flight speed will slow down and altitude will decrease. When packed tightly together, the bird's flight will be much faster and more precise, which is often the case when they are pursuing prey. These special abilities to alter their wings are used in a variety of flight situations, and they enable the bird to achieve exceptional maneuverability. This level of flight control has often made human aircraft engineers stop and take notice. The shorter feathers located inside the wing are not as easily controlled, but these provide the majority of the lift by overlapping to create a streamlined airfoil. Although the Harpy eagle may have a relatively short wingspan compared to some other birds, it more than makes up for this by having an extraordinarily long tail. This tail functions as a rudder on a boat, allowing them to navigate the dense undergrowth. The tail feathers are more uniform in length than the flight feathers, although the degree to which they differ varies between the inner and outer feathers. The flight control system, which is ultimately responsible for the ability of the eagle to fly, is the pectoral muscle. These muscles attach firmly to the breastbone. Both the pectoral muscles and the breastbone are incredibly well developed in birds. This is much more so than is seen in other vertebrates, such as mammals. But the Harpy eagle is even more specialized, and the muscle density in these birds is much greater than that of most other birds. High-altitude flyers, like the Andean condor, have relatively small breastbones and comparatively underdeveloped pectoral muscles. Once such birds have achieved altitude, they hardly ever have to flap their wings. However, the Harpy Eagle, with its short wings, high body weight, and active lifestyle, requires stronger flight muscles than almost any other bird. Aside from their incredible strength in flight, the power of their feet is just as impressive. The harpy's legs are almost as thick as a human wrist. Their large, black, curved talons are even bigger than those of a North American grizzly bear, measuring up to 13 centimeters in length. The Harpy Eagle possesses the largest talons of any bird of prey, and they can exert a pressure of more than 50 kilograms on their unfortunate victims. These talons have been known to shatter bones instantly, and they are capable of snatching prey from trees with more force than a large dog could exert with its bite. This terrifying hunting ability alone is enough to cause great fear among the primates and sloths that live in the South American rainforests. But more than anything, the Harpy Eagle is highly intelligent. It hunts some of the most intelligent prey in the South American forests. This is one of the most fascinating arms races between predator and prey that has ever been recorded. The constant battles for survival in the animal kingdom have resulted in a continuous dance between predator and prey, and those who wish to survive must adapt. The predator must evolve to hunt its prey, and the prey must evolve to evade capture. The simple act of predator and prey has led to many remarkable adaptations. One example of this is the race between bats and moths. The arms race began when bats evolved the ability to use echolocation to find moths in complete darkness. In response, moths evolved ears that allowed them to hear the ultrasonic sounds emitted by bats, which allowed them to avoid capture. Some bats have since evolved stealth hunting strategies using echolocation at a frequency that moths cannot hear. In response, some species of moths have evolved their own ultrasonic clicks that they can use as a defensive tool against bat attacks. This type of coevolution is visible throughout the animal kingdom. For a long time, very little was known about how animals like harpies hunt primates, and how the intelligent primates develop defense mechanisms against these predators. So, researchers began a fascinating study that involved some fairly extreme tactics. Barro Colorado Island, situated in the middle of the Panama Canal, is a biological reserve that is home to a variety of primate species, including squirrel monkeys, spider monkeys, and, most importantly for this research, howler monkeys. The island is home to more than 60 troops of howler monkeys, with each troop consisting of around 20 individuals. Typically, primates will use alarm calls to warn other members of their troop of danger. Different calls signify different threats, such as big cats, snakes, or eagles, allowing them to know what type of danger is present and how to best respond. However, for the past 100 years, the howler monkey populations on Barro Colorado Island had not had to face any major predators. There were no jaguars, very few snakes, and most importantly, no Harpy Eagles until 1999, when 2 radio-tracked Harpy Eagles were introduced to the island by researchers. The researchers wanted to understand whether the monkeys on the island were able to coordinate a response to a predator that they had never encountered before, and if they were not, how long it would take them to develop a defensive strategy. As expected, when the eagles were first introduced to the island, they caused absolute chaos amongst the monkeys. The eagles captured one howler monkey every 3 to 4 days. During these early encounters, the monkeys would either exhibit random and uncoordinated bursts of panic, or they would become completely still and remain unaware of the danger. The monkeys had seemingly lost their ability to recognize and respond to the danger of Harpy Eagles, making them easy targets for these apex predators. But this was not the end of the surprises. One of the most remarkable findings was the hunting strategy used by the eagles when targeting primate prey. Rather than attacking stealthily and quickly, as you might expect, the eagle would sit perched on a nearby tree, in full view of the monkeys, while they were foraging for food. Then, as if to make sure the monkeys were aware of their presence, the eagle would produce a series of unusual calls, which sounded almost unbelievable in the context of the cutthroat world of survival. These calls were always structured in exactly the same way. They were only ever used when pursuing prey, and only when hunting primate prey. Why would the predator make sure that their prey knows they are about to attack? These calls provided the researchers with an essential clue. If the monkeys were to respond to the presence of the eagle by exhibiting random and uncoordinated bursts of panic, the eagle would initiate an attack. Why would the predator make sure that their prey knows they are about to attack? These calls provided the researchers with an essential clue. If the monkeys were to respond to the presence of the eagle by exhibiting random and uncoordinated bursts of panic, the eagle would initiate an attack. Alternatively, if the monkeys were to mount a coordinated defensive strategy, the eagle would simply leave and look for other prey. The Harpy Eagle's calls are effectively used to gather essential information about their prey. By observing what occurs after the call, the eagle gains critical information about the alertness of its prey, as well as its defensive abilities and escape mechanisms. By probing for potential defenses before an attack, the eagle can make a calculated assessment of the risk of the encounter and quickly determine whether that particular prey is worth the time and energy investment. Over time, the monkeys started to develop more coordinated defensive measures. They began to hug their young and move them to more sheltered areas of the canopy. They started to organize themselves into a crowd, and they produced specific alarm calls whenever an eagle was observed. Over the course of a year, almost all of the monkeys on the island had developed a defensive strategy, making the eagle's hunting practices considerably more difficult. The researchers were able to observe a predator-prey arms race playing out in real time, which was an amazing opportunity. Unfortunately, the experiment was only able to continue for 1 year, which was not long enough for the Harpy Eagle to evolve a new hunting strategy that would overcome the improved defenses of the monkeys. After the eagles were removed from the island, the howler monkeys retained their defensive response to recordings of the Harpy Eagle's calls for at least 7 months, which was the duration of the observations. Unfortunately, there is no way of knowing for how long the defense mechanisms of this monkey population will endure. It is incredibly rare for studies like these to run indefinitely, but it was truly a unique insight into the behavior of the Harpy Eagle. It is a clear testament to the fact that the Harpy Eagle is truly an extraordinary predator and a worthy monarch of the sky. So, what do you think about this incredible predator? Be sure to leave your thoughts in the comments section below.